Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of identifying proportional and non-proportional functions. This is standard 8.5H in the great state of Texas, and we are using item number 20 off the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got 4 different problem situations. All we're looking for is which one is a proportional relationship. So we need to first identify what the difference is between proportional and then non-proportional. That's going to help us as we turn these into very simple numerical expressions with some number sentences and x's and y's. So proportional relationships are ones that we use the direct variation equation. So that is y equals kx. And so if x equals 0, well then y would equal 0 if x was equal to 0 here, which means it goes to the origin. All right, so that is what a proportional relationship is. And if you wanted to, you can actually solve these with this simple equation. You can actually make a proportion, right? You could say y over x equals something that modifies y over something that modifies x, like ky over kx. You can use proportion, like we did in 7th grade. Non-proportional is going to use the slope-intercept form. So it looks very similar. It's got y equals mx. Both m and k represent the slope. I don't know why they use different letters there. But it's got a plus b here. It's got something tagged on to the end. So if x equals 0, right, so y would equal b, and that's the difference. So you see how if x is 0, y turns into 2 different things here based on whether it's proportional or not proportional, which means it does not go through the origin. It's going to have a y-intercept. So let's see what our problem situations turn into. We're going to look for one that looks more like that y equals kx, that direct variation. So f, the cost of purchasing a basket, so the cost is what we're looking for, so that's going to be our dependent variable, equals 130 per pound, so that's going to be my independent variable. I'll just put that decimal, 1.3x plus, look at that, they give that to you right there, plus 5. And that is your slope-intercept form. That is non-proportional because if x equals 0, right, then y would equal that 5. That's that slope-intercept. All right, so we're not going to do f. So g, the cost, once again, y, purchasing peaches for $7 per box. So that's going to be my independent variable with a delivery charge. So they didn't say plus, but that's really what we're doing. We're adding $3 at the end. So if x equals 0, y would equal that 3, and that's represented by this b down here as my slope-intercept. So there's no on the g. H, the cost, so we're going to do that. So at least they're not hiding what type of problem these are. We're just going to map these real quick to some number sentences. Purchasing grapefruit for $1.80 per pound. So you notice we're doing this again and again, but it's just per pound, $1.80 per pound, with a coupon for $1 off. Okay, so we're going to minus 1 instead of adding 3 or adding 5, but it still ends up being the exact same form. So let's hope it's J. The cost of purchasing apples for $1.75 per pound plus, shouldn't have that plus, shipping fee of 16 cents, interesting, per pound. So we're going to add 0.16, but it's per pound. So you know what? You can actually combine these right here. You can combine those into 191 if you just put those two x's together, and that is our answer, J.